Hello students, today we will deal with questions of numericals of the acid bases and the salts, which is totally based on to the X-IJSO level. So here is the question number 1. Calculate the pH and molarity of HCl solution 40 ml of which react completely with 30 ml of 0.1 molar CaOH whole twice. So, what is given in the question? The molarity in the volume of the CaOH whole twice which reacts with 40 ml of HCl solution. We have to calculate the pH and the molarity of the HCl solution. First of all, we'll design the relation between the base and the acid, that is CaOH whole twice when reacts with twice HCl, it gives CaCl2 plus twice H2O. Now, firstly we have to balance the equation if the equation is not balanced. If it is balanced, then it is fine. Now, from the equation, it is clear that 1 mole of CaOH whole twice reacts with 2 moles of HCl. In chemical reaction, the moles of the substance, that moles can be different, but if we talk about the gram equivalents, we can say the number of the gram equivalents of all the substances which is taking part in the reaction will be the same, but the number of the moles of all the substance will be different. So, 1 mole of CaOH whole twice is equivalent to 2 moles of HCl, whereas now we can say the number of gram equivalents of CaOH whole twice is equal to number of gram equivalents of HCl. Now what we'll do, we'll just crisscross it to neutralize each other's effect and to get the moles of it. So 2 into n moles of CaOH whole twice is equivalent to n moles of HCl. Now, in a question, it is given that 30 ml of HCl reacts with 0.1 molar of CaOH whole twice. If we focus onto the formula of the molarity, what is molarity? Molarity is equal to number of moles of solute by volume of solution in liter. If we will multiply this molarity into volume in liter, we will get the N, that is number of moles. So now we will put this number of moles of CaOH whole twice by multiplying its molarity and the volume which is to be in liter. So molarity given is 0.1 and the volume is given 30 ml, that is 30 by 1000 liter. Now we'll equate it with number of moles of HCl. Again, by going on to this formula, we know that number of moles is equal to the molarity into volume of a solution in liter, and in a question the volume of HCl is 40 ml. So it will be again molarity into 40 by 1000. Now we will calculate the value. it will come out to be 2 into 0.1 into 30 equal to m into 40. 0 cancel by this is 2 and this is 1. So molarity will be 0.3 divided by 2, which is equal to 0.15. Thus we can say that concentration of HCl is equal to 0.15 molar. Now, after finding the molarity, we have to calculate the pH. Now, we know that HCl, aqueous solution of the HCl on dissociation gives H3O positive ion, or simply we can write H plus ion plus Cl negative ion. From 1 mole of HCl, we are getting 1 mole of H plus ion. So, from 1.5 molar, the concentration of H plus ion will also be a 0.15 molar. Now, how to calculate the pH? We know that pH is equal to minus log of H plus ion. We'll put the value of H plus ion here, which is like 15 into 10 raised to power minus 2. We'll also again split this 15 as it will be pretty arduous or difficult for us to calculate the or to mug up the value of log 15. So we can split it by log 3 multiplied by 5 multiplied by 10 raised to power minus 2 minus log 3 plus log 5 plus log 10 raised to power minus 2. Again we know that log m into n is equal to log m plus log n. So we have added up this multiplication values and log m raised to power n is equal to n log m, which we will use here. The value of log 3 is 0.4771. Value of log 5 is 0.6999. And again plus minus 2 log 10. We'll write 0.4771 plus 0.699 minus 2 because log 10 is 1. So the value comes out to be minus 1.1761 minus 2, which will be equal to 0.823. We'll solve the another question. Question number 2. It is based on to the same phenomenon. Calculate the pH and molarity of H2SO4 solution 250 ml of which is required to fuse 500 gram of CaCO3. So, in this question, first we will derive the reaction between CaCO3 and H2SO4. So, what will be the reaction? That is, CaCO3 when reacts with H2SO4, it forms CaSO4 plus CO2. Now, the data is given for the CaCO3 and H2SO4. So again, we'll make the comparison between CaCO3 and H2SO4. As I said to you, number of moles of the substance will be different or will be same. while reaction, but number of the gram equivalents of the substance will always remain same throughout the reaction. So again, as the equation is balanced, so 1 mole of CaCO3 is equal to 1 mole of H2SO4, but number of gram equivalents of CaCO3 is equal to number of gram equivalents of H2SO4. So, is equal to number of moles of H2SO4. Now, what is given in the equation? 500 grams of CaCO3. With the help of formula, number of moles is equal to given weight by molecular weight. It can be calculated by any method or by either method. The method which we have discussed previously, it is based on to the molarity formula, because in the question molarity and the volume is given, so we have calculated the number of moles by using that formula. But in this question, the weight of CaCO3 is given, so we can calculate the number of moles by making the use of the formula, that is given weight divided by its molecular weight. So its moles will be 500 divided by 100, and the number of moles of H2SO4 will be. Now, as we have to calculate the molarity of H2SO4, now in this case we'll design or we'll calculate the number of moles by making the use of the formula of molarity. That means molarity is equal to number of moles of solute by volume of solution in liters. Number of moles is equal to molarity multiplied by volume in liter. Here molarity is unknown, so we'll keep it as m, and the volume of solution is 250 ml. So we'll divide it by 1000 to convert it. So here molarity comes out to be 20 molar. This concentration is again for H2SO4 solution. Now we have to calculate the pH. So H2SO4 when dissolved in water gives twice H plus ion plus SO4 2 negative ion. From the equation it is clear that 1 mole of H2SO4 is equivalent to 2 moles of H plus ion. So 20 molar will be equivalent to 40 molars of H plus ion. So pH will be minus log of H plus ion, and this will be equal to minus log minus, or we can write it in this manner, 4 into 10. This will be equal to minus log 4 plus log 10. Again log 4 can also be written as minus log 2 raised to power 2, log 10 is 1. So it will be minus 2 log 2 plus 1. This is equal to minus 2 into 0.3010 plus 1, which comes out to be minus 0.6020 plus 1. So in this way we will calculate the value of H2SO4 or the pH of H2SO4. It comes out to be 0.3. Now, third question, calculate the mass of HCl which is present in 250 ml of solution which completely react with 200 ml of 0.5 molar Na2CO3 solution. So what we have to do in this question, we have to calculate the weight of HCl which is present in 250 ml of a solution and which completely reacts with 200 ml of 0.5 molar Na2CO3 solution. Firstly, we will draw the reaction between Na2CO3 and HCl which gives. So now again from the reaction it is clear that 1 mole of Na2CO3 is equivalent to 2 moles of HCl, but number of gram equivalents of Na2CO3 is equivalent to number of gram equivalents of HCl. So 2 into number of moles of Na2CO3 is equal to n moles of HCl. Now again by using the molarity relation we can calculate the number of moles of Na2CO3. 2 into molarity into volume divided by 1000. Here the volume will be in milliliter, and in this case again molarity into volume divided by 1000. So we'll cancel out this 1000. Now 2 into 0.5 into 200 is equal to m into, therefore molarity is equal to 200 divided by 250, which comes out to be 0.8. Now by using the formula of molarity, now we can calculate the weight of the HCl present in the solution. So molarity is equal to weight of solute into 1000 by molecular weight of solute, or the molecular mass of solute into volume of solution in ml. Molarity we have find that is 0.8. Consider weight of solute is W. Weight of HCl is 36.5 and the volume of solution given is 250. So W is equal to 36.5 multiplied by 0. So the value will be 730 divided by 100, which is equivalent to 7.3 grams.